we are saying, what we have been doing so far is this. We were solving exponential equations. And then the exponential equations that we're solving, we had a base as a number, and then we had an index or our exponent as a variable. That's what we've been doing. We have our base as a number, and then we have our variable as an index or as an exponent. What I want us to do today is to look at questions whereby we can have, it's not as if we are doing this for the first time. It's just we're going to do questions that are more complicated than what we've already done. So we can solve questions whereby you can solve questions whereby you have the base as a variable, and then you have the index here. Here's your index. Your index has a number. So you have a base. The difference between this question and the questions that you were doing before, come and check here. We are saying to you, nothing has changed that much. It's just what we are dealing with exponents whereby this went down, this went up. So you have, if we take the following examples that I have here. So we've done something like this before. It's not as if it's something new. Solve for x here. If you're solving for x here, how did you do that one? It's a quadratic. It's a quadratic. How do I know it's a quadratic? It has squared. Again. So since it has squared, how do you solve this thing? We said we can take this to this other side. If we take this to this other side, we'll have x squared minus 4, which is going to be equal to 0. Still remember that? And then we said, okay, but if that's the case, we can open two brackets equaling to 0, and then we'll have x multiplied by x, it gives us what? X squared. And then we'll say, okay, what is square root of 4? Square root of 4 is going to give us a 2 and a what? And a 2. Here we'll have a plus, and then here we'll have what? A minus. Meaning our x is going to be equaling to -2, or x is going to be equal to a 2. Now, it was not a problem when we're dealing with a quadratic, because quadratic we can simply solve it by factorizing. But we're saying to learners we should be careful, because these are not the only variables that we can have. These are not the only indexes that we can have. We can have an index like -2. How do you deal with -2? How do you deal with 1/2, 1/3, for example? How do you deal with something like this, whereby it has an index of -3/2? That's what we are saying now. We are saying, okay, we need to have a method that is going to work, even if this thing here is not a quadratic, it doesn't have a squared. That's what we are saying. Now, you were saying something. You were saying, I could have solved this thing in a simplest way by doing the following. I could have said, okay, I have x squared is equaling to 4. You were saying I should do what? Square both sides. Now, the problem what I didn't teach you how to square both sides is because you forget this. A square both side has a plus and a minus. So every time when you put something inside a square root, it has a plus and a what? And a minus. So plus and a minus here, it says which x is going to be equaling to plus and a minus what? 2. Which means x is going to be equaling to -2, or x is going to be equal to what? To 2. So it's taking us back to exactly where we started. Now, exponentially, when we squared both sides, this is what we're doing. We were removing this 2 here. Now, how do you remove 2? How do you remove that 2? We're going to remove that 2 by multiplying with its inverse. It's called the multiplicative inverse. Now, what is the multiplicative inverse of 2? The multiplicative inverse of 2 is like we are saying you have 2 all over 1. The inverse 2 all over 1 is going to be equaling to 1 all over 2. Are we good? And then what is going to be the multiplicative inverse of 1 all over 3? The multiplicative inverse of 1 all over 3 is going to be equal to 3 all over 1. So how do you get the multiplicative inverse? You get the multiplicative inverse by changing whatever is on the numerator to be on the denominator. Whatever is on the denominator to go to the what? To the numerator. Are we still good then? So we are saying here, basically when we're putting a square root here, a square root, you will see something here. So we have x squared. Let's stick with it. So we have x squared, which is equal to 4. If I wanted to remove this squared here, I could have done this. I could have said, okay, come and multiply with the multiplicative inverse of this thing. Multiplicative inverse of this thing is 1 all over 2. Now we can prove that. But the good news is this. Whatever I do on the left-hand side, I'm also going to do it on the right. So I will have 1 all over 2 here. Let's check that. So if I say 2 multiplied by 1 all over 2, what is going to be my answer? It's 1. Now, guys, we should be careful here. What are we getting? We are getting x to the power of 1, which we don't have to write to 1. You should remember that. There's no need for us to write that 1. And then I'm going to type this in my calculator. But if I continue with this exponential, since I also know the laws of exponents, I can come and say, but now 4 can be written as 2 to the power of 2 multiplied by 1 all over 2. Now, with that being said, what is this multiplied by this? We already know. We said 2 multiplied by this. What did you get? 1. So we should go to x is going to be equal to what? 2. Do you get what I'm saying so far? Now, here, what is the idea here? The idea is that we can be given, let me erase this and then let's talk about it again. We can be given our exponent in a different way than what we are used to. We can be given our exponent such that we have a base as a variable, a number as an index. So now we are used to having something like this, 2 to the power of x. Now we are saying this is and this are all exponents. Now here, if we put 4 here and then we want to solve it exponentially, so how would we do that? We are saying Elena is going to multiply with the inverse of the index, with the multiplicative inverse of the index. So what is going to be the multiplicative inverse of this index here? It's 2, Amish. So if it's 2, the inverse is like you have 2 all over 1. What is the inverse of 2 all over 1? 2 all over 1, the inverse can be written as 1 all over 2. So I'm going to come here and multiply with 1 all over 2. But whatever I do on the left-hand side, I'm also going to do it on the what? On the right-hand side. So I have 1 all over 2 here. Now, if I say this one multiplied by this one is going to give me x. That's the goal. The goal is to have x. Just like if you had 2x is equal to 1, you want to have x only here. How do you do that? You divide by 2, you divide by what? By 2. Now, to remove the squared, for us to remove the squared, how are we going to remove the squared? We are saying to you, you can multiply with the inverse of the exponent. Now, if you multiply with the inverse of the exponent, if we multiply with the inverse there, it says we are going to have x, which is going to be equal to. Now, we can also do this with our calculator, 4 to the power 1 over 2. We can come and do that and check what we get. So we have open bracket, we have 4 to the power of 1 all over 2. If we say equals to, it gives us an answer as what? As 2. Now, here's a problem that I have with this method. It's not a problem. It's not a problem. But the problem that I have with this method is that we know our answer is not 2. What is our answer? I think we've done this thing last year. What should be our answer based on what we did last year? You just did this thing here. What are our answers here? X is equal to -2 or x is equal to what? 2. But what are you getting here? So it's a problem. It's missing one solution. It's missing one solution. How do we solve the issue of missing one solution? Here's what we are saying. We can then do it this way. if we have our index, so if index H, if our index is odd, we are going to have one answer. So we can say we are going to have one solution. If our index is an even, we are going to have two. Now, what do I mean by that? I mean, you can come and check your index here. If you see that your index is odd, you're going to have x is equal to 2, you stop there. If 2 is an even number, you can't have 2 only as your answer. You're going to have plus and a minus 2 as your answer. Yeah, you don't put plus and a minus what? Plus and a minus 2. So based on what we just said, man, let's try this one here. Let's look at this one. I first wanted us to deal with whereby we have an index not as a fraction. We have indexes, sometimes they can be a fraction, but let's stick with an index not being a fraction first, and then we go to the ones whereby an index is a fraction. So if we do this question, let's take it. It says we have x to the power minus 4, which is, no, it's x to the power minus 2. So we have x to the power minus 2, which is going to be equal to 4. Yeah? Okay, based on what we just learned, Manchester City, we have an index here. What is our index here? Minus 2. Okay, let's write our index, minus 2. So we have index minus 2. Our index is minus 2. What is going to be the multiplicative inverse of minus 2? If we want to get 1 here, we're supposed to multiply with minus 1 all over 2. You get that, huh? So we're going to multiply with minus 1 all over 2. It means in other words, so we can come and say to them, okay, we have x minus 2 is equal to 4. We want to remove this minus 2. How do we remove this minus 2? Minus 2 low, we're going to remove it by saying, let's multiply with the inverse of this thing here. If it's negative, obviously, you need to multiply with the negative. If it's positive, you need to multiply with the positive. So I'm going to multiply with minus 1 all over 2. Like this. But whatever I do on the left-hand side, I should also do it on the one on the right-hand side. So even here, I'm going to have minus 1 all over 2. You still with me here? Okay. Now, what happens if you raise, basically what you are doing here, you are raising a power to the first power. You say this one multiplied by this one. If you say those two multiplied by each other, it gives us x. Negative and negative, it gives us positive. 2 multiplied by a half, it gives us 1. We don't have to write the 1. Moving on. This side, how then do we do it this side? Before it was a little bit complicated. Now we have Casio calculators. We can simply come and type this in our Casio calculator. We can say, okay, we have open bracket, we have 4, close bracket to the power of minus fraction. We have 1 all over 2. And then we say we have equals to. What is our answer then? Our answer is 1 over 2. I come and write my answer. Okay, this is me writing my answer. I have 1 all over 2 as my answer. I'm not trying to complicate it here. I have my answer. I'm not done because my index can either be an odd or it can either be an even. So let me come and check here. 2. Is 2 an odd number or an even number? So let's come and check. Even, how many solutions do I have? If it's odd, how many solutions do I have? So since it's even, what am I going to write here? I'm going to say I have plus and a minus. So it means in other words, x is going to be minus 1 all over 2, or x is going to be equaling to 1 all over 2. And then this is me being done with my lesson. Now, since I'm done with my lesson, I can then come and ask you to do the following. As a class work, just try this too.